Next, we look at question 1f. Again, you have two matrices of two different sizes. So we start our first step again. That is to determine the size of each matrix. So this first matrix has 2 rows, 1 column, so it's a 2 by 1 matrix. And the second matrix has 1 row, 2 columns, so it's a 1 by 2 matrix. Again, to check, alright, the middle number coincides, so we know we can multiply the two matrices. Size of the final matrix will be a 2 by 2 matrix, so we know we will end up with a 2 by 2 matrix. Alright, we'll do our usual again. Divide the first matrix up into row and the second matrix up into column. So first element, if you recall, is row 1 times column 1. So you get 4 times negative 5. Okay, second element will be row 1 times column 2. So row 1 is 4 times 2. Third element, row 2 times column 1. And fourth element, row 2 times column 2. So you find that you will end up with a bigger matrix with these elements here. Okay, so hopefully by now you will find that matrix multiplication is quite simple. We will do another example. Right, the next question is question number 3. We are given 3 matrices A, B, and C. So for part A, we are asked to find A, B, and AC. Okay, so let's do a quick exercise finding A, B. So I'll take A times B. Again, we look at the order of the matrix. This is a 1 by 2 matrix. This is a 2 by 2 matrix. Middle numbers are the same. Size of the final matrix will be a 1 by 2 matrix. So we know it will consist of 1 row, 2 columns. Next, divide the first matrix into rows. Divide the second matrix into columns. So for the first element, we will take the first row, so 2 times 3 plus times the first column, 1 times negative 6. Second element, okay, 2 times 4 plus 1 times 5. And we should get 0 and 13. Okay, we will end up with a 1 by 2 matrix. Alright, just to check again, we should end up with a 1 by 2 matrix. Right, next you're asked to find AC, so we repeat the steps again. AC. Alright, we know that the size is the same, so you should get a 1 by 2 matrix. Again, divide the first matrix into row, second matrix into column. Okay, so I know I should expect a 2 by 1 matrix. First element is taking the row times the first column. Second element is taking the row times the second column. And you should end up with 7 and negative 5. Okay, next, in part B, we are asked to find A times B plus C. Okay, so for matrix, we do the same order of operation as we would do for algebra. We will do what is inside the bracket first, so we will leave A and we will take B plus C. So looking at B plus C here, I can add B plus C up straight away. Remember, B plus C means I'm just adding up the elements in B plus the elements in C in their corresponding position. So I'll get 3, 4 minus 2 is 2, negative 6 plus 7 is 1, and 5 minus 1 is 4. So I will get A times this matrix here, and A is actually equals to 2, 1. So again, okay, this is a 1 by 2 matrix, this is a 2 by 2 matrix. First test, pass. Final order is a 1 by 2 again. So to help myself, divide the first matrix into row, second matrix into column. Okay, so I should get the first element 2 times 3 plus 1 times 1. Second element 2 times 2 plus 1 times 4. And you should get 7 and 12. 4 plus 4, sorry, 8. Okay, so then in part C, you are asked to find the relationship between AB plus AC and A times B plus C. Okay, already you can make an intelligent what the relationship is, but just to make sure, okay, we will work out what is AB plus AC. We call AB is 0, 13. AC, we worked out is 7, negative 5. And indeed, you get 7 and 8. So, we can state the relationship as AB plus AC is equals to AB plus C. Okay, and this operation applies for all matrices. Next, you are asked to find in part D A times B times C. So to do this, what we will usually do is we will do it in order first. Okay, it doesn't matter which pair you do first. You can either choose to do B times C first, then use A times B times C, or you can choose to do A times B first, either way. Okay, in this case here, since I already have AB, okay, where I know AB, recall, in part A, I already know that AB is equal to 0, 13. So I will use this as 0, 13, which is AB times C. And if you work this out correctly, you should get this as your final answer. Okay, for the last part, you are asked to decide whether ABC is equals to BAC. Okay, in general, ABC is not equals to BAC. Okay, so this is the difference between algebra and matrices. When you change the order or where the matrix is placed, it does change, okay, the value of the matrix. So, if you don't believe, you can actually work it out. Alright, so you find that we were able to work out ABC. So now you just need to work out BAC. And in fact, even without working it out, okay, you will be able to see that B is a 2 by 2 matrix, A is a 1 by 2 matrix, and C is a 2 by 2 matrix. Remember that we must always check that the numbers in the middle actually are the same. But if you look at this, already at BA, these two numbers here are equal. That means that BA actually does not exist, which means that BAC also does not exist. Well, we have already worked out what ABC is, and we know that BAC doesn't exist, so we know that they cannot be